In this video, we are going to continue our discussion on the section 11.7. This is talking about coordinate systems in three dimensions that aren't rectangular, that's x, y, z. This coordinate system is called a spherical coordinate system, and it's actually very close to cylindrical, kind of, not really. There's some things that we're going to use to help us get there anyways. Okay, so let me explain the system. We have 3 points, so take a look there. We have rho, that is that a Greek letter. We have theta, and then we have phi. It's not phi. Phi is a wrong it's a mispronunciation. It is phi. So rho, theta, phi. All right. So looking at our system, let's take a look at what these mean. We have a theta. Let's take a look at that one first. That theta is just like cylindrical. That theta. Now, notice they did not use R. They used a different letter. If they were going to use the same type of R, they would have used R. But they didn't. They used a different letter called rho, and the rho is the distance from the origin to the point. So if we had the theta and we had rho, we'd have some like point out here, right, that we're going to rotate up, right? And it's not out there, but it's the same R. It's still rotating, but the last thing that's going to decide where to go in up and down, because right now all we have is a theta. We have a rho that we know has to get all the way to the point. We have a theta, but we also need something for the 3 space, so that's when we use our phi. Our phi is the angle from the positive z-axis down to the angle to the point. All right, so 3 values here. We have rho, that's the distance from the origin to the point. So that's going to tell me, okay, I know that if I have a sphere, I can rotate that around and it would be somewhere in there, okay? So that rho is set, right? I can rotate it a bunch of different ways. But what determines where that's going to be is that theta is the rotation from there. So from the x-axis, that determines that. And then we know where that's going to live. It's going to live in the slice there. And to determine where it goes up and down in that slice, that's where phi comes in, from the positive z-axis down to that. Yes, I know it feels like, why in the world would we ever use something like this, right? It seems pretty complicated on a sphere, right? It's a great way to map out a sphere and where it is at. We use this longitude, latitude type things, right? So that is our spherical coordinate system. So I want to explain some of the equations that convert it. You can probably see at the bottom of your notes there, but I do want to talk about where they come from. So I'm going to let this be my positive z-axis, this be my just horizontal, and I'm going to call this z. And then we're going to talk about this rho coming out. So this side is rho. We know this is z, right? Let's do a dotted line there. Yeah, keep forgetting I have this dotted line here. This dotted line. And I'm going to make a phi angle. Okay, out there. I'll make a phi angle that goes that way. Sorry for the noise. There's a helicopter passing over. I live practically downtown. This distance is r. That was that projected distance here. It's almost passed over. I apologize. I don't want to start the video over. I have too many to record. All right. I think it's far enough away. Right. So let's consider we get a right angle here with that r, that z, and the rho and a phi. I can use sine here to relate r and rho, right? Opposite over hypotenuse. This, if I solve for r, is rho times sine theta. I apologize for the train. All right, so r equals rho sine theta. I won't record outside anymore after this video. We can also get some other values from this. Let's start with just the r, x being r cosine theta, right? We're pretty used to this probably from physics. This is our polar form. And let's start replacing things. I'm going to replace r with rho sine phi. and then I keep my cosine theta. So we actually now have a conversion. If I have spherical, rho, phi, and theta, I can get back to x. We can do the same thing with y. That's r sine theta, right? That's going to be rho sine phi sine theta. And that'll be the same conversion, right? As long as if I have rho, phi, and theta, I can get y as well. Now, how you can memorize these, how I have them memorized, is notice, one second, I'm trying. Notice that this is the same as this. Right? They both have that. The only difference is the cosine and the sine. Well, hopefully you already have at this point that x is our cosine theta. We're used to that with physics, hopefully at this point. And if not, you're going to get used to it. It has a cosine, so when I just extend it, I add a rho sine phi to both. It's going to have sine, sine, and sine cosine. I just put them in both. That's how I have that memorized. We do have one last thing. We can take cosine of phi, and cosine is z over, right? Cosine is adjacent over hypotenuse. And if I solve for z, I get z equals rho cosine phi. So there are my conversions. They're down here. You already had them on your page. I'm not going to talk through these and how to convert, but they are there. We will use them. Usually with formulas, I'll tell you what you need to know or how to get around the formula thing if you have to memorize or what not to memorize. I will let you know in my announcement this week. You will see it before you watch this video. All right, let's do a couple examples. I have two for this. The first example, okay, so this is in spherical. So I know spherical is, the first one is rho, is 3. Theta is pi over 4. And then we have phi to be 3 pi over 4. All right, so we're trying to go to rectangular, so we need an x, a y, and a z. So converting, I got x equals rho cosine theta sine phi. All right, so I plug all those in. I got 3 cosine pi over 4 sine 3 pi over 4. All right, I hope you know your trig. I will recommend a calculator if you're rough on your trig. I'll put that in my announcement as well. So 3 cosine of pi over 4, that is rad 2 over 2. Sine of 3 pi over 4, that's going to be, okay, that's talking about the y, and that's in second quadrant. We just get rad 2 over 2. Once we multiply all this out, we get 3 over 2. So x is 3 over 2. Right? The formula for y is rho sine theta, like r sine theta, and then sine phi. So I plug all that in. All right, pi over 4, sine of 3 pi over 4. And when I work all that out, we actually get the same exact thing, because sine of pi over 4 and cosine of pi over 4 are the same answer. Not always, but for pi over 4, they're the same. All right, so we got 3 over 2. And then we have one more conversion to do. We have z. Z is rho cosine of phi. So that is 3 cosine of 3 pi over 4. We already had that 3 times, that's radical 2 over 2, which means we get 3 radical 2 over 2. And actually we get a negative here because it's 3 pi over 4, which means it goes over here. And cosine is x. This is going in the negative x direction for that point right here on the circle. So that's why we have a negative. So that is my z. All right, so z is negative 3 rad 2 over 2, which means my last point in rectangular is 3 over 2x, 3 over 2y, and negative 3 root 2 over 2z. All right, I have one more example going the opposite direction for you. Okay, we have rectangular to spherical, so we have x equals negative 2, y equals 2 root 3, and z equals 4. And we're trying to go to spherical. That's rho theta, right? Rho theta and phi. All right, so we got rho squared equals x squared plus y squared plus z squared. I can plug all those in, right, to save some video time. This is 32 when you plug all that in. So if you need to take a moment to square all that out and try to get 32, please do. All right, that is, to solve for rho, is the square root of 32. Right, there's a 16 that can come out. That's 4. And then we have 2 left inside. So I have my rho. Right, use calculators if you need to. There's a calculator I'm going to recommend. It's a $20 calculator. Ish, $20-ish, I don't know, with inflation and stuff, and when, I don't know what year you will watch this video, so I plan on using them for a little bit. So it's on the cheaper side, though. Okay, our other formula, we have tangent theta is equal to y over x, so if I plug everything in there, I got tangent theta is 2 rad 3 over, all right, 2, negative 2, so we get tangent theta, on arrow, tangent theta equals negative root 3. There's a trick to memorizing this. When it's just a root 3, it's a pi over 3. When it's a root 6, it's a 3, or root 3 over 3. If you need some help with trig, let me know. There are plenty of videos. All you do is, I would look up Professor Leonard for trig and go and watch his videos if you need some help. Theta then, if that's the case, then theta would be 2 pi over 3, and also 5 pi over 3. And it would go on if we were doing more than 360, but we only care about 2 pi. All right, so we have those to choose from. We always go with the angle that's going to be where it's supposed to. This is in rectangular, so let's draw our axes. We got, change colors here, a negative x, a positive y, and a positive z. So that is quadrant 2, and then octant 2 as well, because it's under 4. Okay, so if it needs to be an octave 2, then it's got to be this angle. It's got to be in quadrant 2. So we're going to use that, 2 pi over 3. And then we have one last formula that we can use here. We have cosine of phi is z over rho. So that is cosine phi is equal to, okay, z is 4 over rho, and we solve for rho, that was 4 rad 2. All right, those 4s are going to cancel, giving us 1 over rad 2. If you rationalize, you get cosine theta, that's multiplying by rad 2 over rad 2, right? Hopefully you guys can do this at this point. We get rad 2 over 2. All right, this, I know that this, by the definition of phi, it's got to be between these two. Has to. Think about the way it's defined. So phi, if I take the inverse cosine of radical 2 over 2, I get pi over 4. So that is my last coordinate up there. So the points are 4 rad 2, 2 pi over 3, and pi over 4. This is a lot of trig. If I will, like I said, I'll recommend a calculator that will help with a shortcut of that, where you can try to get your hands on one by renting one. You can rent calculators at most testing centers. I think at Northeast it's at the testing center, but at Southeast it's at the math lab, and then I'm not sure about the other two campuses. I would call maybe and ask where you could rent a calculator if you need one. I don't want decimal, I want radians, so there's a specific one I'm going to put in there that will do that for you. If not, you should brush up on your trig. Like I said, there's some videos I will post. I think I post that dude in my additional help and stuff anyway. Just go dig through his playlist, and you can find a trigonometry playlist. And I know you have plenty of free time to watch videos outside of my videos, being sarcastic. But maybe you can squeeze them in sometime. Calculator may be your best bet if you're struggling at this point with trig.